Okay, we're going to do a quick review of how to solve a quadratic equation using the method of factoring, and today we're only going to focus when that leading coefficient is equal to a positive 1, in which case you might just see it written as x squared rather than a 1x squared. So something that just has an x squared. Now when we're solving using factoring, there's two things we're going to keep in mind in this video. Is obviously we need our leading coefficient to be positive 1. That's the first factoring method. And whenever we're going to use factoring to solve, we're going to have our quadratic equation actually equal to 0. And before we get started, we're going to be using two things of background knowledge. Just first of all, how do we factor with the leading coefficient of 1? And then what is the zero product property? So if you're unsure about both of those, take a moment to go review those before progressing forward. So our first equation here, we're supposed to solve the quadratic equation x squared plus 7x plus 12 is equal to 0. So before we can do anything, we need to make sure that we meet our requirements. So the first thing we're going to look for is our leading coefficient a positive 1? So look at my leading coefficient right there, and it is a positive 1, so we've met that requirement. And we have to check to make sure that our quadratic equation is equal to 0. So when I look there, I can obviously see that it is equal to 0, so we've met both of our requirements. So the first thing we're going to do is factor. So we're going to take this equation here, the quadratic part, and since the leading coefficient is 1, I'm asking myself what numbers multiply to positive 12 and add to positive 7, and of course those are the numbers 4 and 3. So my factors would be x plus 4, and then x plus 3, and of course we know this is equal to 0. So once we have it factored, we're going to use the zero product property. So if we have both of these things multiplied, one of them must be 0. So either x plus 4 was equal to 0, or x plus 3 was equal to 0, in which case we get two possible solutions, x equals negative 4 or x equals negative 3. So our final answer is stating both values that could possibly have made the original inequality true. Now we're going to solve the equation x squared minus 2x is equal to 24. So again, we're going to check our requirements. So the first thing we need to find is our leading coefficient equal to positive 1? When we look at that leading coefficient, we can see that it is equal to a positive 1, so we're good to go there. The next thing we're going to look for is our quadratic equation equal to 0? And unfortunately, this one's not. It's actually equal to 24. So before we can do anything, we must make it equal to 0. So when I make it equal to 0, I want to keep this x squared a positive number. So since it's already positive, that means all this stuff's on the right side. So what I need to do is get rid of that positive 24 on this side. So I'm going to subtract 24 from both sides. So there's going to be a negative 24 on the left side, and we know that 24 minus 24 is equal to 0. So now we do have our quadratic equation that's equal to 0. We've rewritten it, and we can see that now it is equal to 0. So once we're there, what we're going to do is we're going to factor it. So what numbers would multiply to negative 24, but would add to negative 2? We're going to use those numbers to help us with our factorization. And of course, we would be able to see there that our numbers are going to be negative 6 and positive 4. So we get x minus 6 and x plus 4. So now we are going to use that zero product property, which says if we have two things, this number being multiplied by that number, and their product is 0, either the first number was equal to 0, or that second number was equal to 0. So we get our solutions of 6 or negative 4. Alright, our next example is negative x squared plus 11x is equal to 30. So as we're looking at our requirements right now, we could see that we don't meet any of the requirements. Our leading coefficient is not a positive 1. It's actually written as a negative 1. If we look at it, is our equation equal to 0? It's not. It's equal to 30. So we have to rewrite this, but now what we're looking at is there's multiple ways that we could rewrite it. With this one, I want to keep the x squared positive. So what I'm going to do is I'm actually going to move everything over to the other side, because if I add x squared and I subtract 11x's from both sides, I can see that negative x squared and positive x squared is just 0. Positive 11x and negative 11x is also just 0. And then over here, I'm just going to rewrite my terms. So I'm just going to simplify a little bit. 0 plus 0 is equal to 0. I might rearrange this equation here and put the x squared minus 11x plus 30 in standard form. But once we're here, we do meet our requirements. It is equal to 0, and our leading coefficient is 1. Nobody says that they have to be on the left or the right side of the equation, so we're ready to go ahead and factor this one then. So if I am looking at this side of the equation here, what are the numbers that would multiply to 30 but add to negative 11? We would use those to help us complete our factorization here. And of course we could see that those numbers are negative 5 and negative 6. So we have x minus 5 and x minus 6, which means if these two numbers multiply to be 0, one of them was 0. Either x minus 5 was equal to 0, or x minus 6 was equal to 0. So x could have been 5, or the x value to solve the equation could have been 6.